Hey, it's Miss Pfalzgraf. I wanted to make a video to help you better help your child as they study for their test tomorrow. They should have brought home today a common assessment review or a common assessment practice. As you can see, it's titled on the screen right now. Um, I just wanted to walk through it kind of quickly and show you how I tried to teach them to use strategies in the classroom. Um, on this first one, I did want to note that they will be asked to show their thinking. In fact, the directions say you must show your thinking. If they do not show their thinking tomorrow on their test, they will be losing a point for not failing to have showed their thinking, as the directions said. We have reviewed all the strategies of drawing a picture, using related facts, double facts, 10 frames, number lines, counting on, counting back, even rewriting it to be in standard algorithm form. All of that is fine. We just need to know how to, what line of thinking did they use to get their answer. So on this first one, we have 6 plus 7. So they could have drawn a picture 1, 2, 3, 4, 5, 6 plus 7, 1, 2, 3, 4, 5, 6, 7 to count and define 13. They could have started at the bigger number and counted on. So 7, 1, 2, 3, 4, 5, 6 more. So 7, 8, 9, 10, 11, 12, 13. They could have drawn a number line. They could have, with addition, this is kind of the easiest one, but I did have one child who said, well, I know that 13 minus 7 equals 6, so then 6 plus 7 should equal 13. Those related facts kind of come more handy when they're using the subtraction, especially with checking their work, which I strongly urge them to do when we get to word problems. But here, again, they could have drawn a picture of 18 circles and taken out 5, and that would have left 13 as well. Could have counted back. So if we start at 18, count back 5, 1, 2, 3, 4, 5. So 18, 17, 16, 15, 14, 13. Any of those strategies work well. They could have done a number line. Again, related fact, well, if I know that 13 plus 5 equals 18, then 18 minus 5 must equal 13. Okay, our next one was the missing add-ins. This is where I saw some of our more kids struggle with. They wanted to add together 4 and 11 instead of looking at it as a missing add-in. And I tried to remind them that it was kind of like our part whole of, well, I know my biggest number is 11 and I have 4. What am I missing? Okay. And so if we think about, so I know 4 plus this would equal 11. Well, then 11 minus this would equal 4. But I still need to rework it so that this is on the end. So 11 minus 4 would equal this. So 11 minus 4 equals, so, and again, they could draw 11 circles. They could count back, whatever they needed to find 7. And they fill it in. This one doesn't require them to show their work. I did urge them to, just because some of them struggled. So here, 7 plus something equals 10. Again, they could look at it as a part whole with 10 as my whole, 7 as a part. What goes here? Again, they could have drawn circles. So 5, 6, 7, 8, 9, 10. Okay, well, if I have 7 of them, how many more do I need? 3. Anything that'll help them, all of those addition, subtraction strategies, especially some of those related facts, come in handy here when they're looking for those missing add-ins. Here is where majority of the class struggled on some of the next ones. These balanced equations, we had a lesson last week and we talked about these are balanced. So find what one side equals and the other side has to have the same value. So 6 plus 9 I know is equal to 15. Well, then 10 plus what is equal to 15? And again, they could rewrite it. So 15 minus 10 would equal 5. Okay, and on some of them I even rewrote it that 6 plus 9 equals 15. Well, then on this side, 10 plus what has to equal my 15 as well, and they were able to find that it equaled 5. So to model this one again, 6 plus 4 is equal to 10. 2 plus 8 would also equal to 10, just making sure that this side has the same value as this side. A lot of them did well here. I did notice some of them like would only add the first two or the bottom two numbers, and I had to go remind them to add all three. A lot of them, I was very proud. They found those 10 friends, and so 10 then 5 more would equal 15. Or I saw some that were like, oh, well, I know 7 plus 7 is 14. 3 more is 17, using those double stacks or near doubles or make 10 facts. All those are great here. But I do try and encourage them, even as we get to adding 3 and 4 two-digit numbers, or even 2 two-digit numbers, that try and add 2 and then add the other one, whatever order that may be. All right, and the last one, this is another one that I noticed a great many of them struggle. I'm gonna make it a little smaller. I don't know why it's so big. So on their review and on our test tomorrow, this question similar to this will be set up where it has my part whole, and then over here it says X equals. And I've tried to use the X, especially when we're working on missing add-in word problems, so that they've kind of gotten familiar. I tried to remind them that, so then 9 plus X should equal 16 here. Or if we think of it as a facsimile, so 9 plus X equals 16, X plus 9 equals 16. Well, then I can swap it around. 16 minus 9 would equal X. 16 minus X equals 9. So then here is where my X is on the other side of that equal sign. So 16 minus 9, X would equal 7. And I told him again, here I can draw, 9 circles, 5, 6, 7, 8, 9, and then could circle those. All right, so I have 9. How many more do I need to get to 16? 10, 11, 12, 13, 14, 15, 16 to find that it's 7 more. Or even count up. Several use their fingers to count up. But I just saw a lot of, they were trying to add these two numbers to make this number. And I had to remind them that this is my whole. These two add to make this one, just like in our fact families. I hope that you have found this helpful. Please reach out to me. I will try my best to answer any questions tonight that I can, or possibly tomorrow morning when I get to work early. Any way I can help, let me know. Thanks.